Hello, my name is Riley Pointer, and this is my fifth lab report for Physics 1, which I have decided to do on collisions. So, for this lab, we were allowed to choose sort of our own experiment to model physical principles on. So I decided to do mine on physics and to just answer and then my purpose was to model elastic collisions and determine if there's any correlation between the difference in mass and the change in momentum between the two objects that are colliding. So, little explanation. So, as we know, the principles, well, momentum is conserved during collisions, but that doesn't mean necessarily that the momentum of an individual object is conserved, just the total momentum of the system. My goal is to basically see if the difference in the mass of the two objects colliding plays a significant role in how much momentum is transferred between each colliding object. So, for the initial conditions, so ball one was my constant. It's just had a constant mass and radius of one. Ball two mass varied between 1 and 5, with its radius being determinate based on its mass. And both balls had initial velocity of 2.5. So after did the results in VPython or GlowScript, this is the results I got. So first off, the table. So as you can see, obviously, the initial and final momentums are the same, as you can see from this box right here and this box right here, which is, of course, expected with the conservation of momentum. And since it is an elastic collision, the initial and final kinetic energies are the same. Over here, I also did the final, as you know, the initial velocity of each ball is 2.5, and over here I have the final velocity of each ball. As you can see, obviously out in the first go, both balls stay the same as they were completely identical. So the transfer of momentum and speed was of course constant and equal to each other. But as you can see, as ball two grew larger, it slowed down after collision, while ball two significantly speeded. While ball two took all it of ball one. Sorry, ball two slowed down, while ball one took all of ball two's velocity. Interestingly, on attempt three, when ball two is 3 times the size of ball one, there's going to be a 100% transfer of velocity, which you can also see modeled over here. Also, interestingly enough, from when the mass was 4 times and 5 times bigger, the momentum was so great that the ball two still continued to roll even after the collision. And this bar graph is meant to represent the ratio of momentum transferred to masses. So as you can see over here, the ratio is 0 to 0 because the transfers canceled out because the final momentum of each ball after collision was equal to essentially the inverse of its starting collision. But from here on, as ball two began to transfer more momentum, so it actually lost a greater momentum. Oh, I get actually probably some errors with how this was set up. But anyways, it continued like this for a while. Okay, so then I asked the question, what if the mass was significantly greater? So in this scenario right here, ball 2 is 100 times greater than ball 1, and as you can see, ball 1's momentum is massive compared to ball 2's. And not only that though, ball 2 still has a significant momentum in in the same direction as ball 1's motion. And that means the same direction as the motion, same direction it was initially traveling in, which means that yeah, the mass of one ball, the mass difference between them plays a significant role in the transfer of momentum. So yeah, this experiment has confirmed that the difference in the masses of two objects in a collision plays a role in how much momentum is transferred from one object to the other in an elastic collision.